discuss about the peering session. So how basically BGP, when two BGP devices are there or two BGP speakers are there, how they will able to form the neighborship between them, right? Basically how whenever they send any information, so whenever BGP speaker sends any information, so what is the transport mechanism we have with BGP? Whenever we configure anything in BGP, so whenever we configure in BGP, we need to specify the neighbor. So we need to specify the neighbor as 172.16.12 dot, let's say 1, right? Here we need to, from here we need to specify the neighbor as 172.16.12.2, right? So what is the reason of this? Because we need to specify the neighbor for BGP under the configuration, because there is no hello mechanism like in OSPF or ISIS they will discover. We just need to enable OSPF and ISIS in the interface, they will able to discover, right? There is no discovery mechanism. We need to explicitly say that to BGP, this is your neighbor. So, so basically the transport mechanism. So BGP in general use transport mechanism as TCP. The reason is basically it needs to offload certain things, like it needs to delegate certain things like error control, right? For example, you need to have MD5 checksum between them. So you need to have authentication mechanism between them. So MD5 also relies, we need to have delegate that to TCP. We need to have also sequencing, which is the important mechanism for TCP. Also, we need to do like any kind of retransmission that is needed. So whenever BGP sends any kind of update and that is being lost somewhere in middle, then retransmission should be required as well. So that's the reason also we delegate to TCP, right? Other also things that reliable transport and all the TCP features are in that. So you can go, you can refer my TCP video in order to get into more about TCP. BGP forms a relationship between them whenever there is a neighborship is there, or whenever BGP wants to have a peering session, right? So for example, let's say R2 wants to have a peering with ISP1, right? So what will happen when it will form a peering session, right? So BGP first of all needs to initialize the TCP socket. So in terms of so as it relies, the transport mechanism relies on TCP, you need to initialize that TCP socket. So based on this initialization, whenever we talk about anything about TCP, then it's about always things about the layer 4, which is port, right? So whenever it sends any information or initialize, for example, R2 and ISP1, initialize the TCP session. So it needs to have a local TCP port. So what will be the local TCP port? So local TCP port, it randomly generated, and it will be greater than port number 1024. Anything beyond 1024 will be used by BGP as a source port. So whosoever initialize that, you will use this source port. And for example, R2 wants to have a peering with ISP. So what the port destination port that is being needed is basically port number 179. So well-known port number for TCP, which is used by BGP. So any port beyond 1024, destination port 179, right? So whenever we are talking about the session forming, right, we'll discuss that. So based on, for example, in our example, R2 wants to have a session with our ISP1. So this side 172.16.12.2, this side 172.16.12.1. Autonomous system as 100, autonomous system as 1 from a R2 perspective. So whenever they start, whosoever starts basically the TCP session, right? So that is what referred to as an active, and the responding side will be as passive, right? So what will happen here is active will send a TCP three-way handshake, initiate the TCP three-way handshake, and basically it will be TCP, and it will send a SYN flag. So it is a TCP packet, sends a SYN flag with the TCP. We'll have some source port. Let's say source port is somewhere like 11111. This is randomly generated, and the destination port is 179. This is a well-known port will be used for BGP by TCP, right? And then it will also send a MSS value in a TCP option. For example, if you configure like authentication mechanism, right? For example, MD5. So whenever you configure MD5, also MD5 checksum also goes within the TCP in the SYN packet. Okay, so MD5, whatever the value is, let's say in my lab that I configure as Cisco, so it will go within the TCP SYN packet with MD5 as value as Cisco, right? So once it receives, right, active sites sends that, and once it receives, so it will send back with TCP packet, and this is now SYN plus ACK. So SYN plus ACK is nothing but SYN, whatever the, for example, sequence number it sends with the SYN flag. So it will do a +1 to that, and then send an acknowledgement. So it is sending its own sync plus the acknowledgement for the previous packet. And then now the source port is 179 and the destination port is 11111. And it will also send its own MSS value, and it will also send the MD5 as Cisco if it is configured as Cisco. If it is not, then it will not come up. It will remain there in idle state. So, and then basically it will do a ACK. ACK for what? ACK for this SYN packet what ISP1 is sending, right? And then it will be source port and destination port will be like this. So remember that unlike other protocols, BGP do not have the capability, like for example, do a auto discovery. So BGP always do a manual, right? So we need to what? We need to define the neighbor details whenever we do the configuration, so that based on this neighbor detail, we will have a TCP session formed. So BGP neighborship is always divided in two parts, right? So for example, if I say, let's say we have BGP and BGP neighborship we want to form, first part will always be the TCP, right? So first is TCP. So TCP session has been there with, basically it will as an active and then passive. We have three-way handshake. Based on that, it exchange some values and the port numbers and the link IP addresses based on the source and destination, right? The other part is the BGP perspective, BGP messages perspective. As soon as the TCP three-way handshake completes, right? So the TCP three-way handshake has been done now. Immediately, the active neighbor will send an open message. So this open message contains the information about this neighbor. What is the order number system? What is the address family identifier? What is the subsequent address family identifier? AFI value and SAFI value. Whether it's let's say AFI is IPv4, SAFI is let's say unicast, right? Or but let's say VPN, AFI unicast, VPN unicast is eVPN. For example, what kind of values are there? It will also send a graceful restart capabilities as well. So this is what an open message being sent by R2 as an active. The moment it sends, what will happen? It will transition to OpenSent phase, right? So it will transition to OpenSent phase, and it will restart its connect-retry timer. Based on this connect-retry timer, R2 will wait for ISP1 to respond with that. So R2 will wait that, okay, let's say I am waiting for ISP1 to send me the open message so that I can confirm. For example, if this connect-retry timer expires, right? So what will happen if within this connect-retry timer, for example, let's say connect-retry timer is, let's say 1 second. Within 1 second, if I do not get open message from my neighbor, then the connect-retry timer is expired and R2 will transition from OpenSent to active. So R2 will go to transition to active phase state. Okay. If, for example, within the connect, the ISP1 respond with open message, right? This open message will contain its own values and own parameters. So open message sent by within the connect-retry timer, basically open message sent by ISP. So in that case, it will compare the values. It will compare the values based on what all been there, like AFI, SAFI, AS, and all, right? It will compare the value from the configuration, whatever this is configured, and based on that, it will compare it. Once it is compared, if everything is fine, so what R2 will be going to do now? It will going to do a OpenConfirm. State change to OpenSent to OpenConfirm, and now, so basically what will happen is it will send a keepalive message. So once it sends a keepalive message, that means my open message what I sent and the open message what I receive from my neighbor is matched, right? SAFI value, AS numbers are been validated. Then I will transition to OpenConfirm. After I transition to OpenConfirm, what I do, I will send a keepalive message, and then I will transition to establish. So BGP, whenever, for example, we talk about BGP. So BGP peering session starts with TCP. In this TCP stage, I will have the stage is first idle. So stage is idle. Then we will have connect and active. These are all the stages of TCP side of it, right? So when after the TCP session formed, the moment TCP session formed will enter into the BGP phase of it. So BGP will send a open message and transition to OpenSent. Restart the connect-retry timer. Wait for the neighbor to send the OpenSent message. Once I get that open message from my neighbor, I'll compare and then say that OpenConfirm. OpenConfirm, I'll send a keepalive, and then I will do a establish. So these are basically two phases when we talking about BGP. So this is important to understand because this will use in terms of whenever you are troubleshooting anything in terms of BGP. When BGP will idle state, what all conditions are there? If you understand the flow, like for example, there are multiple things will be there. So now let's understand the each phases of it. So idle phase, right? What will happen when it's in idle phase? So let's understand what will happen in case of idle phase, right? So BGP is an idle phase. So this is a initial state, right? So this is an initial state of BGP, and then it will preparing for the transport, right? So active the initial sequence number and all, right? And then it is basically preparing for the TCP three-way handshake. So these are all the states. Basically, these are all what happens when it's in idle state. So once basically it starts, basically BGP starts the session and three-way handshake initiated. If three-way handshake initiated, it will start with a timer, right? And then if three-way handshake completes within, means it sends a three-way handshake and then it have a three-way handshake session is completed, then it will, so it will in the connect phase, what will happen is three-way handshake initiated, timer starts, it will transition to connect phase. If in connect phase itself three-way handshake completes, then what will happen? It will transition to immediately BGP will send a open message and transition to OpenSent. Okay, so basically here in this phase, here timer starts, and then here TCP three-way handshake success, and then it sends an open message and OpenSent, transition to OpenSent, and then what it will initiate? Basically it will initiate the connect-retry timer. So if the connect-retry timer to wait for my neighbor to send the open message to me. So that's the reason. How much time I will wait? I send the open message. How much time I will wait? So I will wait till this and then I will do something. So for example, if connect is there and then what happened, TCP is not successful, so it will transition to active phase. So basically in this phase, my TCP session is not yet success. TCP is success over here. This is not yet success, right? So basically what will happen, if for example timer expires, there is a timer starts here, timer expires, again it will try. So it will trying for TCP session to again do a three-way handshake. If timer expire again, then it will go to idle state. So this is timer expired. Okay. So timer expired, active to connect. Again it will retry. Again timer expired, it will go to this. Okay. So this is also comes in red. This is the failure part of it, right? So now, for example, if OpenSent is there and I receives an open message, I will do a OpenConfirm. So OpenConfirm is there is no error. We compare that and I will transition to OpenConfirm, send a keepalive and then go to transition to establish phase. Okay. So what all happened here? OpenSent, BGP establish, OpenSent, waiting for the peer to send back. I receive an open message, compare that, I'll transition to OpenConfirm. I will send a keepalive and transition to establish if everything is confirmed. Okay. But thing like if there is an error happened, if I am in OpenSent and based on this OpenSent, if error happened, I matched and I got that, okay, there is a mismatch in the AFI and SAFI value. So it will transition to, okay, if there is an error. If there is connect-retry timer expires and I didn't receive the OpenConfirm message, I will transition to active. Send again, retry back sending the open message. If hold down timer expire, I didn't receive any kind of keep alive, still I will transition to idle state. So establish, anything happen, any tier or any restart or any condition happens based on the notification message. So from establish also I can go to idle. So this is what basically the BGP state is all about. And this is about how it is transition from idle, connect and active. Idle, connect, active is a part of TCP. OpenConfirm, establish is a part of BGP. There are different messages associated with this. So first thing is we have what? Open message. Open message, I send all my capabilities, everything related to BGP, right? AFI, SAFI, AS number, next hop, everything. Graceful restart. Second is the keep alive message. So keep alive message is basically, it is used for checking my neighbor, right? For example, we send a hello message in order to check whether my neighbor is up or down, what happened. So keep alive message is basically to check my neighbor, right? Remember one thing, so like in OSPF and ISIS, for example, R1 is there and then we will have R2. What happened in OSPF and ISIS? So basically during the formation of neighborship, they exchange the routes like LSAs or LS updates, right? Or LSP, you can say that, link state path for ISIS, or LSAs update, LSUs are basically for OSPF. So during the neighborship formation, they form the neighbor as well as their routing table is also exchange whatever the routes they have. They exchange the entire topology information, everything. But here with BGP, first thing we need to establish, then after establishment, it will send an update message. It will send an update means it will send the update message. Another type of message it is update, which is used for sending what? It is used for sending the NLRIs, the prefix information. Okay, so update message, route, everything. BGP will advertise the route after your BGP session is established. And then another message we have is notification message. For example, here we have seen a notification message is sent, and due to some error or something happened, tear down or reset something, and then it will, from establish itself, it went to idle. So these another message types are also there, but here in this, what we have discussed is open message, keep alive, notification, update we'll discuss as well. So let's do a lab, and then based on that lab, we will able to analyze just how we will configure it, which all show command in order to check the summary of BGP, and then what all neighborship, what is parameters that we are exchanging during, and how if we configure, let's say MD5, what will happen if I configure MD5 in both the sides, then where this MD5 message is being exchanged is basically in the TCP header itself. In the TCP option field, we will have an option to send the MD5 information. So here I'm doing what? Here I'm configuring R2 with its neighbor as 12.11, which is ISP1, and giving the remote AS as 100. So similarly, I need to have configured R2 side as well as our ISP1 side, both. So if I do a show IP BGP summary, basically show IP BGP summary will give us the BGP update, means what is the status. Now 12.11, it has been idle state. So I need to configure other side as well. So I need to go ahead and configure in ISP2. So in ISP2, basically I need to give as my router ID, means my autonomous system is 100, and the neighbor I'll specify as 12.2, and the remote AS as 1. Now if I'll go ahead and see that this neighborship is an up, 12.2 is up, which is my R2. And if I do show IP BGP neighbor, show IP BGP summary, so basically it will give me the neighbor status of BGP. Then what I can do is, now it's up, I'll go ahead and check about the neighbor from R2 perspective. Earlier it was showing us down, idle. Now it is showing up after I configure both the sides. It's simple configuration. Just we need to define the neighbor with the autonomous system to make your BGP up and running. So this is very handy command. And also I can go ahead and see the neighbors of what is the neighbor details. Whenever you are doing a troubleshooting perspective, you can do a neighbors details. Based on this, it shows you the capabilities, and for example, what is the state of BGP, what is the version number, right? Remote router ID and BGP state, what is the hold down timer and the keep alive timer, and how many notifications everything has been sent. So this will give you an picture of your network. Now, so basically I will go ahead and configure change the hold down timers, right? So if I'll go ahead and configure the hold down timer, so basically I need to go inside the neighbor and then do a timer along with the keep alive timer as well as hold down timer. First is keep alive followed by hold down. You need to, for example, we have keep alive timer, for example, we configure, right? Different. So it will always negotiate. That does not mean if there is a mismatch, it will neighborship will be teared down. Remember that. So whenever I have a BGP configured with a lower values, that does not mean BGP will tear down. That will be there. So it will negotiate based on the values. Okay. So now I'll go ahead and configure here as in ISP1, the timers as 10 and 30. 10 as in keep alive, 30 as in hold down timer. So every 10 seconds I will send the keep alive. If for 3 keep alive miss, that means I will say that okay, my neighbor is down. So in order to get it effect, if you configure and see the neighbor status, it will not show you the information about the new hold down timer configure. So basically for that you need to clear the BGP session. See here hold down timer and 180 and keep alive is again 60. There is no change because already we configured. Now we need to restart the BGP process. So once we restart BGP process, basically the timer will again negotiate, and based on that they will come up with the new configured value. So now its new configured value is hold on 30 and keep alive as 10. So this is the keep alive. Now we will go ahead and configure a password for the neighbor, like MD5 password, right? So for that we need to go inside BGP, define the neighbor, and then put the password in order to have a MD5 between R2 and ISP1. How that will be transported? That will be transported within the TCP option field. If there is one side you configure, other side you do not, then BGP will not come up. So we need to configure, you make sure that you need to configure both the side, and the password should be same across. So if you see that BGP peer closed, down peer closed, the reason which says that it down peer closed is basically we configured, and any keep alive message or any TCP message it went. So basically BGP says that okay, there is a MD5, and then we need to configure the MD5, and then it came up. So now BGP is in established state. So what all we covered in this topic is, first of all, BGP peering. So how we will have peering established between BGP, how the BGP messages are being transported, what is the transport mechanism it uses, it's used TCP, what all states, how many, means for example, in terms of BGP peering perspective, BGP peering perspective is divided in two parts of it. One is TCP, where you will doing a three-way handshake, and we will have state like idle, connect, and active. We will have BGP states. So in that BGP state, basically what we have is we will have OpenSent, OpenConfirm, and establish. And then we also saw that okay, when from, for example, what will happen once it sends an open message, and based on this open message, basically it will wait how much time it will wait to transition to the OpenConfirm. What will happen if I do not receive a open message from my neighbor, and then if I receive an open message, I'll compare and the value is correct, how it will be transitioned to establish, right? And then we did a config perspective, we did a configuration of BGP and how it means which all parameters are needed to configure. Very simple configuration. This is all about BGP peering.